Power rule means the differential coefficients of x to the power n is equal to n multiplied by x to the power n minus 1. In case 1 and 2, we showed that it is going to be true when n is a positive integer, and in case 2 when n is a negative integer. Here we are going to show that it is going to work when n is a rational number like 3 divided by 11 in this example. Before going to prove that in general, let's take a simple example. Let's say y is equal to x to the power 3 divided by 11. First thing we do is we raise both sides to the power 11. Then this side becomes y to the power 11. What will happen in this side? 3 over 11 times 11 becomes just 3. So our next step is to differentiate this whole equation with respect to x. But before going to that, let me show you something. Say y is equal to x to the power 11. Then all of us know that the differential coefficient of that is 11 times x to the power 10. We can replace this y by x to the power 11 because y is x to the power 11. Now I'm going to show you one more thing. What about this one? I replace the x by y because y is another letter in the alphabet. So this is also true. The differential coefficient of y to the power 11 with respect to y is 11 by 10. So please keep that in mind. We are going to use this little later. Now we are going to the exact question. Y to the power 11 equals x to the power 3. As I said earlier, we have to differentiate that with respect to x. The first step to do is we have to put do dx in both sides. Then after that, we shift our dx a little bit to the left hand side. This side becomes 3x squared. Next step, we put extra dy here. And then we put a bracket like this. You might call this implicit differentiation. This way it's very easy to understand for a beginner. Now what is this one? That's the differential coefficient that we are looking for. Let's call it y dash. As I said earlier, this is going to be 11y to the power 10. After this, we have some simple algebra. Divide both sides by this one. Replace your y by x to the power 3 over 11. And the next step is multiply this. 3 over 11 times 10 becomes 30 over 11. That is this one, 30 over 11. And then we have to subtract the indices. 2 minus 30 over 11. You can see it clearly here. Take the LCM. It becomes minus 8 over 11. So you can see clearly now that when it is a rational number, it is going to follow the exact power rule. See, 3 over 11. 3 over 11 minus 1, that is minus 8 over 11. So we showed that it is going to work for a rational number too. Now we are going to show the same thing in general. Instead of taking a real number, let's call it n. So in general we call it x to the power a over b, where a and b are integers. As we did in the last simple example, what we do is we take the bth power from both sides. So become yb, this side b and b will cancel and become a. Then differentiate the whole equation with respect to x. And maybe we put do dx in both sides. Then what is my next step? The easy way to understand for a beginner. We shift your dx a little bit to the left hand side. If you can remember the next step, you put extra dy up and down like this. Then put brackets. As I said earlier, this is the differential coefficient that you are looking for. Let's call it y dash. We are differentiating a function of y with respect to y, so it's very easy. It becomes by b minus 1. After that, our simple algebra. Divide both sides by by b minus 1. And replace your y by x to the power a or b. Play with the indices. A times b minus 1 divided by b. Then subtract the indices. I have shown you clearly here what will happen. When you take the LCM, ab minus b minus ab plus a. These two will cancel. You get a minus b. Divide all the terms by b, a over b minus 1. So your index is going to be a over b minus 1. So you can see when your n is a rational number, your answer is a over b x to the power a over b minus 1. That means the power rule works when n is a rational number 2. So this is my case 3 of the power rule proof. So the importance of taking a piece of paper and trying to prove these rules is you can get rid of your fear of your calculus. You will love calculus. Calculus is actually a very easy subject, and you have to keep on working on that. Thank you.